Today in this video, we are going to see how to make unique ID in our distributed system. By the end of this video, you will be seeing a lot of techniques by which we can make a unique IDs in our distributed system. And by the end, you will be able to understand about the Snowflake that was implemented by the Twitter. So first of all, we are going to take a simple example of a school in which there are going to be a roll number and there are going to be an ID assigned to them. I should write name here and the roll number here, but whatever. So basically there is going to be ID and it is assigned to a name. Again, ID and name, ID and name. In an e-commerce website, if we go, then again we have to follow this unique ID here. For every order that a user has made, there is going to be an order ID. Okay, and what they have ordered. Similarly, 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, 7, 8, 7. Okay, we are not maintaining any order here. Here you will notice in the school, there is going to be an order 1, 2, 3, 4, 5, 6, incremental order. Now we are going to talk about the transactions. If you'll notice in the transaction here, then you will see that I have mentioned some kind of a pattern. What is this pattern? So see, think of it. 2026 and after that I mentioned 183, basically day of the year. So let's say 183rd day of a year. After that it is going to be some number. Basically that number is 86,400. That is the number of seconds in a day. Okay, and after that there are going to be 4 random digits. That is what our Indian UPI is following, and that supports us up to 9,000 transactions per second. Okay, so that is a very huge number of transactions. In Indian UPI right now we are going to have 9,000 transactions per second, but this whole logic can support up to 10,000 transactions per second. That is very great, huge achievement. And this thing also provides us a very good information. Think of it, this data will also tell you this transaction happened at what time, because it is storing the date technically in very less time. Basically we are not storing the complete timestamp, we are storing the year and then the actual day of that year and the second, at what second the timestamp, at what second that transaction happened. Okay, so we understood about the school, e-commerce and the transaction example. Now we are going to talk about the mindset. So basically think of it, their simple mindset for a unique ID is that it should be unique and does not mean random. Okay, either we can make some random IDs, but the problem with the random IDs that it can, first of all, it can collide. Secondly, it will not provide you some valid information. Think of it, these IDs are providing some information right now. Like if we try to disintegrate them, basically we will be able to figure it out that it is giving some information. But the random IDs will not give that. Unique does not mean consecutive. So here you will notice we discussed about 1, 2, 3, 4. So we should not make always consecutive IDs. The problem in the consecutive IDs is, so let's say a new person will come. Okay, so its ID is always going to be 5. Sometimes in the case of school, okay, it is fine. But let's say if we want to make a secure system, and let's say if we add a new service of a new user is going to come, everyone in the system will know that this user ID is going to be this particular number. This is the whole problem with the unique and the consecutive IDs. Okay, so we want our system to be consecutive and it should give us some reliable information. This is the main purpose. Now we are going to see the functional and the non-functional requirement. So the functional requirement says that generate a unique ID in a distributed system. That is our first requirement. Second requirement says that ID should fit in 64 bits. That is our second requirement. Think of it, if we are talking about some other company, let's say MongoDB or let's say Google, then this requirement will be something different. We don't have to fit our number in 64 bits. Okay, so this thing I want you to remember it till the end of the video, because there are some other ways as well by which we can make unique IDs, and it is not required that we have to make it in 64 bits. Let's say if we want it in 64 bits with some valid information, this approach is one of the best approach. Now it should be sortable in some order. New ID is going to be, of course, greater than the old ID. It should help in sorting. I can ensure that there should be a sorting. Basically, it should be in order, but it doesn't matter that it should be consecutive. Okay, it should be sortable, but I didn't mention here that it should be consecutive. Remember this thing as well. We will discuss about it later. Now we are going to talk about the non-functional requirements. So basically, low latency, high availability, security, and 1 lakh ID per second. Like we have to support at least 1 lakh ID per second. But by the end of this video, this number is going to be like even more greater. Like we will be able to fulfill this requirement easily. Okay, so low latency, that we will be able to make it very fast, highly available, that system should not go down, and security, of course, the things should be secure. If we make all the things consecutive, then it is going to create a problem, like someone will figure it out. So this is the non-functional requirement of the system. Now we are going to see one general table. I made it in the starting so that you know some basics. In our general table, you will notice that we have our database auto increments, per shard counters, range allocation per zookeeper, central ticket service, timestamp only, UUID, and the Snowflake. These are the basic methods. By the end, I will show you something more. Okay, so I'll not tell you the basic idea, main advantage and the main problem right now. We will move forward and we will just cover each one of them one by one. First of all, we are going to talk about the solution one, database auto increments. In the database auto increment, what happens? See, there is one table where we have ID and the roll number. Simple, the same table, we are maintaining the ID. So what we usually do in our database auto increments, we make one table, and this is the schema that we follow: ID in auto increment keyword with a primary key. The name equals to varchar, so basically name will come here and the auto increment. So whenever a new entry will come, so what is going to happen? It is going to just increment by 1. So let's say if a new person's name is going to be added here, let's say David, in that case we will get the value 5. So this is a simple database auto increment. Advantages are simple, easy to understand, small IDs, natural ordering, work well for the small systems. Think of it, if we have more IDs than int 64, basically like int max, then what is going to happen? In that case, I'll just tell you one thing. It is very funny, but the thing is that database will give you an error of repeated number, basically this ID already exists error. Reason being, because database will increment the counter, but by the int max plus 1 is still going to be int max, it is again going to put the same value and it was going to give you the same error because that value is already existing into the database. But think of it, the database should handle it in a good way, that it should give an error that like I cannot make more numbers than this. You have to increase the basically this data set size. You have to, instead of int max, you have to go for long max or something. Now we are going to talk about the problems. Every write depends on a database or a counter. Whenever we are going to make a unique ID, it is going to be dependent on a database. So database can become a single point of failure in our case. It can become a bottleneck that I mentioned, single point of failure. It can become very difficult when data splits across many databases. Right now we have only one database and everything is sorted, but think of it, many services are there. They are just dependent on one database right now, but that we have to increase the databases and everything is just dependent on one service, and that can become a bottleneck. This is a problem with this database auto increment. And secondly, it is consecutive. It can create a problem. It can also lead to security breaches. We understand this. Now secondly, now we are going to talk about the database auto increment per shard. So in this, what we are going to do, we saw the problems in one single database. So what we do is we make multiple shards. Basically, multiple databases are running. So when multiple databases are running, they are going to maintain their different tables. Okay, so this is a different table in one shard. This is a different table in one shard. Now, again, let's say they both are starting from 1. So they are going to have a different combination. So here you will notice. So the first shard will make numbers like this. 1 1 1 2. So basically 1 is common. This is the shard, it is denoting the shard number, and these numbers are again auto incremental, and so on and so forth. Similarly, in the second shard, it is going to be 2 2 2 2, and here these numbers are again going to be incremental. Okay, so we discussed about it, how the numbers are going to be in the same incremental order here. The only difference is like we can make more numbers. Systems is distributed now, like there is no single bottleneck. This is the second thing. Secondly, the creation is in a simple way, okay, the same way, but like we are going to run this query in 2 different shards now. Each shard can generate a ID locally, but remember one thing, now again we are calling the database. So database is something like we are again adding a network hop right now. Problems. Now we are going to talk about the problems. The shard number must be managed. This shard number is 1 and this shard number is 2. Let's say a new shard added, its shard number should be 3. Okay, these shard numbers cannot change. So we have to manage these shard numbers. Again, one more complexity. ID may expose the shard structure. Again, a security breach. Think of it. If someone understood that one dash means the first shard, two dash means the second shard. So again, someone will understand about the security. Adding or removing shards become more complicated. Yes, of course. Because when we are going to add a shard, then we have to manage that this is the shard number somewhere. IDs may not follow global time order. Now they are not following any order, of course, like 1, 2, 3, 4. They are just a numerical number. They are not providing any information. Same happens here also. They are just numbers. They are not providing any information. Now we are going to reach to the third solution. Allocate range of IDs. Now what that means is that there is going to be one coordinator. Okay, this coordinator, we are going to see what does this coordinator do. So basically this server A will make the IDs between 1 and 1000. The server B will make 1000 and 2000, server D 2001 to 3000, and 3001 to 4000. Now what that means is that we will make one service, let's say ticket service. That's responsibility is to make the IDs. So that ticket service, multiple services are running in that. And what we are going to do, so whenever a service, let's tweet service want an ID, it will call the ticket service, and it will take care that server A will make ID in the range 1 to 1000, server B will make 1000 to 2000, D will 2000 to 3000, and so forth. Now these will never collide. Basically, if server A is making 997, server B will be making 1001. They are in different range, so they will never collide. And the simple logic can be they are always going to make an incremental order. Simple, nothing fancy. Server A is making different IDs in different range, B in different range, and once server A make 1000 IDs, in that case what will happen? This coordinator will figure out that this A has generated all the IDs. In that case, this coordinator will assign another range to server A. Similarly with server D also, it will assign us another range. So this is how allocation range of IDs work, or you can say ticket service system work. How we can make this coordinator? So basically this coordinator can be a zookeeper. Basically these zookeeper will manage the range of this service. And once this particular thing is over, basically once the range is completed, zookeeper will assign another range. One more thing that we can do is we can also use zookeeper to create an IDs. Zookeeper can also create IDs. So zookeeper manages this folder like structure in which it will say order/order an ID order, and like it will always going to give you a 10-digit ID, and it is going to be an incremental order. So we understood two things. First is zookeeper, when we can use it as a coordinator in these servers. Secondly, we can just use a zookeeper which can also generate an incremental IDs in a folder like structure. So there are two things that I wanted to teach. Now we are going to talk about the advantages. So the center allocator is not contacted for every ID. Basically, we are not going to connect with the coordinator for every single time. Think of it, a request will come to the ticket service and it will just connect with the server A or server B. It will get an ID. Simple as that. Now, generation is very fast. Once the servers have their ranges, basically we got this range, and then everything is pretty sorted. Once we get the range, these servers are ready to just make the IDs. These are the simple advantages. Now we are going to talk about the problems. The first problem is a crash server may leave unused ID. So let's say if we are talking about the server C. Server C has made all the ID, let's say from 3000 to 4000, it makes the ID till 3600. Now after 3600 to 4000, this server is crashed. In that range, that 400 IDs are going to be wasted. This is the problem in this whole approach. Secondly, the server eventually need another range. After this 1000, we have to provide another range. Let's say that in our case, coordinator is going to provide another range, or you can say zookeeper is going to provide another range. Let's say some flaw occur while providing another range. Then again there is an issue. ID generation at the same time may be far apart. Yeah. Basically the ID generation, let's say the first ID that we generate is let's say 2, and another ID then we generated from server D is let's say 2999. Okay, so there can be far apart. Global time ordering is weak. Again, there is no time ordering in the whole thing. Range allocator is still an important dependency. Okay, this coordinator is still a bottleneck. Of course, think of it, coordinator is again distributed. Basically, if we talk about a zookeeper is again the distributed system. So like, but it can still become a bottleneck. This is what it is trying to explain. Now we have discussed the solution 3. Now we are going to talk about the custom logic. So according to the need, let's make an ID. Think of it that we are going to talk about the Indian UPI system where we do have to where we have to do a lot of transactions. So when I was like dealing with the UPIs at some point of time, so here we came up with this logic. Okay, that's why I mentioned it, this logic: year, day of the year, time of the day in the millis. Okay, time of the day in millis plus 4 random digits. Okay, plus 4 random digits. So basically that idea is going to be milliseconds, and in the milliseconds we are going to have 4 random digits, and let's say we are going to put these digits in the cache for 1 second, and after that we are going to again going to change it. Okay, how many transactions we have processed in that millisecond. So think of it, in the millisecond there are 4 random digits, so it is going to be very hard to breach. Okay, like it supports a lot of transaction, more than up to 10,000 transactions it can support. Logic 3, nanoseconds plus 4 random digits again, and then again we are going to store it into the cache for some breach. Let's say two requests come at the same time, same nanoseconds, and after that 4 random digits. Let's say both the digits are also same, but the cache, let's say if you're talking about the Redis, that is single threaded, again if we're going to put it into the cache, it will still give an error to another ID. So it is also very safe approach to generate. This one also very safe to generate, and this one also milliseconds plus 4 random digits. So this is the basic idea. And if we talk about a simple systems, we can just simply go to our any library, let's say in Golang or in Java. Okay, in anything we can just simply take nanoseconds and random digits. There is a very less chance that they will collide. Okay, so you don't have to be very, like say if you are not making a very big system, you can just simply go with the nano IDs as well. Okay, now we are going to talk about the advantages and disadvantages. Plus, before advantages and disadvantages, I want to see, sometimes I feel like that is my experience, that sometimes you have to go for the simplicity as well, and not every time you have to go for the complex systems. This is my overview. When in this logic 2, this is highly good logic because it provides you sorting, day of the time, at that which time the transaction actually happened. So it can reveal you the timestamp. It is maintaining high number of throughput. So everything is covered. So that's why sometimes you can go with the simplicity instead of reaching directly to the very tough logic. Now, we are going to talk about the advantages and the disadvantages. One place, the one like there is going to be one system that is going to generate the unique ID. So one place control uniqueness. ID can be short and ordered because we are maintaining the length of the ID, basically milliseconds, and this logic as well. We are maintaining the IDs. Okay, and after that, application server stays simple. Like everything is pretty simple right now. This logic can be generated in different services as well because the code is going to be same. Now disadvantages. Every ID need a network call because if we make a separate service, that's why I mentioned this in a disadvantage. Service can be a bottleneck because the logic is like integrated into that service. Running several services can be a bottleneck, and clock rollback. Okay, so we discussed about the custom logic that we can generate. Now we are going to discuss about the solution 5, UUIDs, very famous and like very commonly used. So in the UUID, what we do is these are the very long IDs, okay, like this. But the problem is I think they are 128 bits, and in the 128 bits, basically 32 hex decimal digits into 4 bits equals to 128 bits, and they are usually written like this: 8444412. One more thing I wanted to mention, this look like these are numbers, and we store sometimes them into string, but we don't have to do it. When we store them into the database, we should store into 1828 bits because the size is going to be fixed. We should not store them as string. Okay, if we store them as string, then we do a string comparison, but these are actually the 128 bits. Now we are going to talk about the advantages and the disadvantages. So can be created on almost any machine. No central counter is required. Collision probability is extremely small. We can use them. But we are making this video for the Twitter. Okay, this was the whole thing. We need 64 bits, but it is 128 bits. Going to take a lot of space, like double the amount of space that is required. We need 64 bits, but it is going to take 128 bits. That is not the requirement. It is large to store and transmit. That is what I was trying to say. Random UUID v4 values are not naturally ordered by creation time. Okay, we need sorting, we need ordering, but it is not provided. Okay, we don't want consecutiveness, but they are not ordered properly. Twitter specifically required a value that fit in 64 bits. That's what we have covered. In UUID v4 there is no time. Okay, UUID v6 there is time. So of course we can go with UUID v6 that fulfill like a lot of requirements. And think of it, one more thing, in UUID v7 there is a time. Basically there is going to be ordering, plus there is a random discussion engine. So I mentioned a spatial discussion that we will do about it. Is some companies using UUID v7 because everyone's requirement is not 64 bit. Okay, now we finally reach to Snowflake Twitter, and that is what Twitter had made. So I mentioned one thing very clearly: Snowflake is not the best ID system for every application. It was a strong fit for Twitter specific requirement. We are using it Snowflake at so many places right now, and it was a strong fit for Twitter because Twitter just need a 64-bit unique ID. So how Twitter made it? Let's see it. We have to understand like how the 64 bits are divided. So one bit is a signed bit. Second bit is 41 bits timestamp. Third is the 5 bits data center. 5 bits are for workers and 12 bits are for the sequence. I made it little small. One sign bit, 41 timestamp, and I mixed these two, data centers and the timestamp, like 10 machines and 12 sequences. We'll come up with this thing, okay? How we are going to make it, we'll do a discussion about it. First of all, let me just tell you how many combinations we are going to achieve by this. Okay, so we are talking about the bits. So basically 0 and 1 combination is going to be there. So if 0 and 1 combination is going to be there, so it is 2 to the power 41 plus 2 to the power 5 plus 2 to the power 5 and plus 2 to the power 12 combinations. That give you that many combinations. So in our requirement, it was mentioned that 1 lakh requests per second, 1 lakh unique IDs per second, but it is way more than that. That is the power of Twitter Snowflake ID. It is going to generate so many IDs. It can generate so many IDs in 1 single second, and they all are going to be unique. Now we are going to see the combination. We are going to understand this part, data center and the worker part here. Think of it, these are the data centers, 1, 2, 3. Okay, and let's say we are going to have 5 data centers and there are going to be multiple workers running. Okay, and there is an entry point. Basically the entry is coming, user's request is coming to generate the unique ID. It will go to the data center. So it going to get one ID. Basically let's say it get ID 1 here. It from data center B it will get the ID 2 at ID 3. At A1, A2 and A3 it is going to again get some ID, and there is a sequence also. So we are going to come to the sequence later, but the thing is here we are going to get 2 to the power 10 combinations between the data center and the worker combination, because 5 data centers and the 5 workers. And one more thing that I missed it here is about the sequence. So now I missed one more thing, the timestamp here. That timestamp will come after this machine, the machine at what time the machine is working, and there is going to be a sequence, an incremental sequence. Now we are going to talk about the uniqueness. A request will come, it will go to a data center. After that it will go to a worker, and now worker have their own timestamp plus incremental sequence. So this is the uniqueness. So think of it, and another request will go to another data center, another worker, and of course there is going to be a sequence and a timestamp. To be unique, like if the two requests have to collide, what is the probability? They should go to the same data center, then they should go to the same worker, then that request should be on the same timestamp, and after that they should manage the same sequence. And of course sequence is incremental again, how they are going to have the same sequence. This is the complexity that Twitter has built to generate a unique combination of ID. Now Snowflake ID are roughly time ordered. Okay, so they are not again time ordered. The problem is that these data center are going to be there, maybe they are at the different times. Okay, and secondly, let's say if we manage the times here, these worker can be on different time, but let's say if we manage the timestamps here as well, after that there can be a clause queue problem. Let's say we manage that as well. Here comes the sequence. Okay, because we are putting some random sequence. If you think of a time ordering, let's say we these data center A1 generate some time ID, and this C3 generate the same ID, like timestamp same, data center is, let's say, same, and the worker is also same. Almost everything is same. But the thing is that this sequence will create a problem, because this sequence and the sequence of any other server is going at a different speed. Basically, this sequence is different. So again, that is going to create an issue. Okay, because everything is like, it is not going to provide you an actual order, because every service is maintaining a different sequence. This can be one more thing to generate, to maintain the sequence. What we can do is we can just put a zookeeper. Now zookeeper can, what the zookeeper can do, zookeeper can manage a range for, again, for workers. Okay, that is an approach that you can do. But like, if they want to manage a different sequences, that of course they can do, doesn't matter. But if you want to put a zookeeper here and manage a different range of sequences for some reasoning, you can do that. So this is how Twitter Snowflake unique ID generation work. Now we are going to discuss about the advantages and the disadvantages of the Snowflake ID. So ID for 64-bit generation is pretty fast. Every machine is generating their own ID. Workers do not coordinate for every ID. Basically, every worker is just able to make the ID. It is not dependent on databases or anything. Every worker can make the ID. It scales up by adding the workers. Basically, you can add more workers, you can add more data centers as well. ID are roughly time ordered. They are time ordered, but roughly. Like, there can be a little difference because the sequence is the only problem. Other than that, everything is ordered. IDs are suitable as database keys. Yes, 64-bit is very suitable. It is integer suitable. The system avoids one global counter on a normal generation path. There is no global counter. The timestamp can be derived from the ID if the epoch or layout is known. If ID, the timestamp can be derived from the ID if the epoch and the layout are known. Okay, important point. This is the timestamp, 41 timestamp. That can be taken out from the ID. This is the information that I was talking about. That in some of the IDs we are not able to get any information, but here we can get some information. This is the important pointer. Now we are going to talk about the disadvantages of the Snowflake. Machine clock must be managed carefully. That I told you, there can be a clock skew problem here as well. Worker ID must be unique. Like, these worker ID should be unique every single time. They cannot collide. ID does not provide perfect global ordering. Yes, we discussed about it. The number of the workers is limited by the chosen bit allocation. Yes. ID reveals some information about creation time. Yeah, it reveals some information about the creation time. Like, once the user figure it out that they generated from this data center and this worker. So next time, only the timestamp is going to be different, but the data center and the worker combination is going to be same every single time. So it can reveal some information, but it is not harming them that much. So I think that they have chosen this whole approach. We left one discussion about the UUID v7, but I'll give you some more context. What big tech companies are using nowadays? This is something that we should know. So we know that Twitter is using Snowflake. Very good. Discord is also using Snowflake style ID. Discord documents a Twitter Snowflake system design, timestamp, worker process. The same way Discord is also generating. Shopify, ULID for some idempotency keys. BuildKit is using UUID v7 for new tables. We studied about it. In the UUID v7, we get the timestamp plus random digit ordering. The same thing that Snowflake is providing in with so much combination. The problem in UUID v7 is it is 128 bits, but it is not that big number. Think of it. Instead of 64, it is 128. It is double. But if someone is making a system right now, they can make it. Like, they can make an ID of 128 bits. GitHub GraphQL APIs opaque string IDs. Google Cloud Spanner use UUID v4 or distributed sequences. MongoDB use object ID. Okay, now finally I'll show you the last two things. MongoDB uses object ID. So this is the format of an object ID, and this is the Shopify payment that we were seeing, that ULIDs. Okay, but I want you to study about it a little bit. So basically in the MongoDB, we have the 4 byte timestamp. These are not bits, these are the 4 byte timestamps, 5 byte random values, and 3 byte counter, the random counter that we get in our MongoDB ID, that we get object and the brackets and the ID. So this is how the MongoDB generates an ID. And this is how the Shopify generates an ID according to their needs. And like Shopify has the different kinds of way to generate an ID. But this is the whole discussion. Now we understand the Snowflake, and it generates a 64 bits ID, and we can also use with UUID v7 plus, because it provides the timestamp, ordering, and the random value. So this is it for the video. This is it for the video. We have covered so many things in this video, that how we can make an ID in different ways. I'll put the vlog in the description. You guys can go and read it. And thank you for watching me, and we will meet in our next video, and bye bye.